In June 2024, NVIDIA became the most valuable company in the world. Not Apple, not Microsoft, not Amazon. A chip company. A company that most people couldn't have named 10 years ago briefly surpassed $3 trillion in market value, more than the entire GDP of France. And the question everyone asked was, how did this happen so fast? The stock had risen over 800% in 2 years. Analysts were either calling it the most justified valuation in history, or the most dangerous bubble since the dot-com crash. But here is what almost no one explained. NVIDIA's rise is not a stock story. It's not even a technology story. It is a story about who controls the infrastructure the entire world now depends on, and what happens when that infrastructure is controlled by almost no one. Because the chips inside NVIDIA's most powerful systems are not just products. They are the new oil. And just like oil, the question that matters most is not what they're worth today. It's how long the world can keep running without them, and who controls the supply. Think about the last time something in your life stopped working because of technology. Your phone slowed down after an update. Your car threw an error code. Your doctor said the imaging machine was down. These feel like inconveniences, but they're actually symptoms of something much bigger. In 2021, Americans waited months to buy a new car, not because factories stopped running, not because workers went home, because one tiny chip, a semiconductor used in the car's electronic control system, was out of stock. The chip cost about $1. The car it was supposed to go into cost $40,000. Ford, General Motors, and Toyota collectively lost over $210 billion in revenue that year because of missing chips smaller than your thumbnail. That is the world we live in. A world where the most critical component in the global economy is one most people couldn't identify if you put it in their hand. Here is the thesis of this video, stated plainly. The modern global economy does not run on oil, gold, or dollars. It runs on silicon. Specifically on transistors, microscopic switches etched onto chips that process information at speeds the human brain cannot comprehend. Every smartphone, every data center, every military radar system, every self-driving car, every AI model, all of it depends on chips. But here's the part that changes how you see the world. The ability to make the most advanced chips is controlled by fewer companies than you'd believe possible. And those companies are concentrated in a handful of countries, which means control over the chip supply chain is effectively control over the future of the global economy. And most people have never thought about this for even 30 seconds. Meet Marcus. He's 34 years old, lives in Portland, Oregon, and works as a software engineer for a mid-size healthcare company. His job is to build the software that runs diagnostic tools in hospital systems. He's good at his job. He makes a solid income. He assumes the infrastructure beneath his work is stable. In early 2022, his company started getting alerts. The medical imaging hardware they relied on, MRI-adjacent scanning tools, was being delayed by months. Not because of software, not because of the hospital network, because the chips those machines required were back-ordered. A hospital in Sacramento had to delay non-emergency diagnostic procedures for 3 months while they waited for hardware that couldn't ship. Patients waited longer for results. Doctors worked around outdated equipment. And Marcus, sitting in Portland writing code, couldn't do anything about it. Because the bottleneck wasn't software, it wasn't staff, it wasn't funding. The bottleneck was a piece of silicon manufactured in one country, by one company, using machines that only one other company in the entire world knows how to build. Marcus had spent his entire career assuming technology was abundant, distributed, and resilient. He was wrong about all three. Here is the first hidden rule. The production of advanced chips is not distributed across the global economy. It is violently concentrated. TSMC, the Taiwan Semiconductor Manufacturing Company, produces approximately 90% of the world's most advanced logic chips. Not 40%, not 60%, 90. One company, on one island, an island that sits roughly 100 miles from the coast of mainland China. Think about what that means for a moment. Every advanced chip inside Apple's latest iPhone is made there. Every chip powering NVIDIA's most powerful AI accelerators is made there. Every chip inside the Pentagon's most sensitive computing systems is made, or depends on components made, there. And the machines required to manufacture those chips? The extreme ultraviolet lithography systems that etch transistors at scales almost too small to conceptualize. Only one company on Earth makes them. ASML, based in Eindhoven, Netherlands. And ASML itself depends on more than 800,000 precision components sourced from suppliers across the world, including the United States, Germany, Japan, and South Korea. This is not a supply chain. This is a single, incredibly fragile thread connecting the entire technological civilization. Pull it, and everything stops. Here is the second hidden rule. Chips are not just economic, they are weapons. Not metaphorically, literally. Modern military systems, precision missiles, surveillance drones, electronic warfare platforms, satellite guidance systems, all depend on semiconductors. The country that can produce the most advanced chips can also produce the most advanced military technology. This is why, in October 2022, the United States government did something that shocked the semiconductor industry. It imposed sweeping export controls on advanced chips and chip manufacturing equipment going to China. Not trade restrictions, not tariffs, a near-complete technology blockade. American companies were banned from selling the most advanced chips to Chinese firms. American citizens were effectively banned from working for Chinese chip companies without government approval. ASML, a Dutch company, was pressured by the United States to stop shipping its most advanced machines to China. And the reason this was possible is the same reason it was necessary. Because the global chip supply chain runs through American intellectual property, American software, and American allied manufacturing. No country building advanced chips can fully escape American influence over the process. The United States didn't just use economic leverage, it used its position at the center of the global chip ecosystem as a geopolitical weapon. And China, which had spent a decade and hundreds of billions of dollars trying to build a domestic chip industry, found itself years, possibly decades, behind. China's response was to accelerate domestic investment to an unprecedented scale. The Chinese government has committed over $150 billion to its domestic chip industry since 2014. And yet, as of today, China still cannot produce chips at the frontier level. The reason is not money. The reason is not engineers. The reason is that ASML will not sell its most advanced machines to Chinese companies. And without those machines, the laws of physics make frontier chip manufacturing essentially impossible. The export control wasn't just an economic sanction, it was a ceiling. A technological ceiling placed on the ambitions of the world's second largest economy. The chip war had been running in the background for years. Most people only noticed when their phone got more expensive. Now let's zoom out. Because what's really happening here is something much older than semiconductors. Every era of human civilization has had a single resource or technology that determined who held power. For centuries, it was land. Then it was coal and iron, the raw materials of industrialization. Then it was oil, the fuel that ran the 20th century economy. Each time, whoever controlled that critical resource controlled the terms of the global order. We are living through the transition to the next era, and the critical resource is not a raw material. It is the ability to design and manufacture chips at the frontier of physical possibility. NVIDIA, a company started by 3 engineers in a Denny's in San Jose in 1993, became one of the most valuable companies in the world, not because it makes good graphics cards. It became that valuable because its chips became the essential infrastructure for artificial intelligence. Every major AI model, every system that can write, reason, generate images, diagnose disease, analyze satellite imagery, runs on NVIDIA's data center chips. Training a large AI model without NVIDIA hardware is, for now, practically impossible. That is not a competitive advantage. That is a structural monopoly on the infrastructure of the next economy. This is why the United States passed the CHIPS and Science Act in 2022, a $280 billion commitment to rebuild domestic semiconductor manufacturing. Intel, TSMC, and Samsung were offered billions in subsidies to build fabs on American soil. It was the largest industrial policy investment in American history. And it was driven by one recognition: that allowing advanced chip production to remain concentrated overseas was a national security risk too large to ignore. But here is what most coverage of the CHIPS Act missed entirely. Building a semiconductor fabrication plant takes 5 to 7 years from groundbreaking to first chip. The machines to equip it take years to manufacture and deliver. The engineers to run it take years to train. America is not going to fix this problem with a press conference and a subsidy check. The dependency took 40 years to build. It will take at least a decade to meaningfully reduce. And here is the counterintuitive insight that almost no one discusses. The countries and companies winning the AI race are not necessarily the ones with the best engineers or the most data. They are the ones with access to the chips. A team of brilliant researchers with no GPU access cannot compete with a mediocre team with 10,000 H100s. Compute is the new capital. And like capital, it is not evenly distributed. Here is what should unsettle you. We have spent decades being told that the modern economy is resilient, that globalization distributes risk, that free markets self-correct, that technological progress is inevitable. The semiconductor crisis revealed that none of these things are straightforwardly true. The global economy is extraordinarily fragile, and it is fragile in a very specific way. It is fragile at its most critical nodes, the nodes no one was paying attention to. Consider this. If TSMC's manufacturing facilities were destroyed or cut off from global supply chains through natural disaster, conflict, or political decision, the global economy would face a disruption worse than anything since World War II. Every major economy on Earth would begin running out of advanced chips within months. Cars would stop being manufactured. Hospitals would face equipment shortages. Data centers would stop expanding. Military systems would degrade. The United States government has modeled this scenario. The conclusions are classified. But the fact that they're modeling it tells you everything. And yet, until a few years ago, no politician, no economist, no major institution treated this as a crisis in waiting. Because the chips were invisible. They were inside the thing you used, not the thing you thought about. Marcus, sitting in Portland, spent years building software on top of hardware he never thought about. He assumed it would always be there. That assumption, multiplied across an entire civilization, is the vulnerability. Here is the thing about invisible infrastructure. It only becomes visible when it fails. Roads are invisible until the bridge collapses. Water systems are invisible until the pipe bursts. Electrical grids are invisible until the power goes out. Chips are invisible until the shelves go empty. And we have built an entire civilization on top of infrastructure that almost no one understands, produced by a handful of companies, concentrated in a handful of places, dependent on machines that only one company in the world knows how to build. This is not an accident. Complexity has a way of hiding its own fragility. The more sophisticated a system becomes, the harder it is to see where it might break. And the harder it is to see where it might break, the less motivated anyone is to fix it, until it breaks. The chip shortage of 2021 was a warning. The export controls of 2022 were a signal. The race to build domestic chip capacity, happening right now in the United States, Europe, Japan, South Korea, and China simultaneously, is a recognition. A recognition that the world's most important infrastructure cannot remain invisible any longer. But here is what history teaches us about critical infrastructure and power. Whoever builds the next layer of invisible infrastructure first, whoever becomes the indispensable node in the next network, holds the leverage for the next generation. The chips most people will never see are not just products. They are the architecture of who gets to decide how the future is built. And the question worth asking, the question most people are too busy to think about, is simple. Who's making that decision? And is it you?